All right, so the lab we'll be performing today is the molar mass of a volatile liquid. So what happens if someone hands you a liquid and they ask, what is this? So here's our liquid and they ask, what is this? How could you figure this out? So let's take a look at a bit of a simplified view of this. So the question we're going to be answering, is this ethanol or is this cyclohexane? Right, so two different chemicals. Which one is it? The formula for ethanol is C2H5OH, and then the formula for cyclohexane is C6H12. So how are you going to answer this question of what is this unknown liquid? Well, one thing you could do is take a look at the molar mass of the two compounds and see if they're different or the same. So let's take a look at the molar mass of these two guys. So this one weighs approximately 46 grams per mole, and this one weighs 84 grams per mole. So you can see they're quite different. So if you could figure out the molar mass of the unknown liquid, you could identify which one of these two it is. So naturally, the next question is, how do we find the molar mass? So let's take a look at what molar mass is. If you think about the units of molar mass, it's how many grams per mole of the compound, right? So it's going to be grams over moles. So we need to figure out these two components, divide one by the other to get the molar mass. So let's think about how we're going to find these. The first component, grams, that seems kind of pretty simple to find. We can just weigh something and know its weight. So that shouldn't be too difficult. What about this mole part, though? This part's going to be quite complicated, right? You can't go shrink yourself down to the size of a molecule and count individual molecules. And even if you could, it would take an eternity just to count out one mole. So how are we going to figure this part out? And so this is the kind of more complex part. And we'll take a look at how we're going to do it. And we're going to basically use the properties of this volatile liquid to do that. So a volatile liquid is one that is easy to vaporize. And so what that means, it's easy to transform it from a liquid to a gas. So let's check out how we're going to use this property of our liquid to find how many moles and then the molar mass of our liquid. So first thing we're going to do is we're going to go ahead and grab an Erlenmeyer. Looks something like this. And then we're going to fill it with some amount of liquid, right? Some of our unknown liquid. And then we'll use some aluminum foil with some holes to cap this off. So there's holes in it so the liquid can, or once it turns into gas, it can escape, but not all too quickly. Next thing we're going to do, we're going to heat this. I'm just going to write heat, but what you'll be doing is using a water bath to heat this. And so since it's a volatile liquid, it's easy to vaporize. What's going to happen when we heat it? And then the correct answer there, since it's a volatile liquid, it'll go easily from a liquid to a gas. So draw the gas, something like that. And this gas at the beginning will be free to escape. Once there's a whole lot of it, it'll escape pretty quickly. But once the pressure inside of the vessel and the pressure, the atmospheric pressure is approximately equal, this escaping is going to actually slow down quite a bit. And so for us, we're just going to pretend that it doesn't escape. And so now we've got a gas in here and it's at atmospheric pressure. So we're at pretty low pressure. And so we can say that this gas is behaving ideally. Right? And so if we think about an ideal gas, we have a famous equation for that. And that it's that pressure times volume is equal to number of moles times the gas constant times the temperature. Right? And right here in this equation, we have number of moles, which is exactly what we want to figure out. So we can take this equation, go ahead, reorganize it to solve for number of moles. So we're going to divide both sides by RT. And so you'll get N equals PV over RT. So if we know P, V, R, and T, we can figure out our number of moles, and thus we can figure out the molar mass. So let's take a look at each one of these components. The pressure of the gas, well, since our container is open, we know that this pressure of the gas will be equal to the atmospheric pressure. So all we have to do is use a barometer to read the atmospheric pressure, and then it's going to be the same in the vessel. So equal to the atmospheric pressure. Next up, we have volume. Well, if we think about the volume our gas is occupying, it's going to be the volume of the Erlenmeyer. Next up, we have R, and that's a constant, so we don't have to really worry about that. We know what that value is. Just make sure that whichever gas constant you're using, that all of your units match, right? You have to make sure all of your units match. And then finally, temperature. Well, since we're heating it in a water bath, the temperature of the gas inside the Erlenmeyer is going to be in thermal equilibrium with the water bath. So this temperature is going to be equal to the surroundings, which is going to be, again, the water bath. So you can see we can figure out the P, V, R, and T of this gas, which means we can figure out N, which is the number of moles. So there we go. Boom, we've got our number of moles. So what do we do next? We just have to then weigh our apparatus. So we're going to let this cool. And once we let this cool, this gas is going to go ahead and condense. And that's totally okay. It condenses, you know, kind of around the Erlenmeyer little kind of bubbles. That's totally okay. All the gas is still in there, so we can go ahead and weigh it. So we can take the weight of our Erlenmeyer with our liquid in it and our empty Erlenmeyer, subtract the two, and then we've got our weight. So we've got our grams from the gas properties. We've got our moles, grams over moles, molar mass. So then you can calculate and you can answer the question of, is this ethanol or is this cyclohexane? All right, so the first step is to obtain your 125 mil Erlenmeyer. So going left to right, A, B, C, D. Which one of these is going to be your Erlenmeyer? Yep, it's going to go ahead and be this one right here. And so what you want to do after this is you want to cover the top with some aluminum foil. Secure it in place with a rubber band. And then maybe just rip off some of this excess pieces. There we go. And then using a pin, go ahead and poke some holes into the top of the aluminum foil. Cool. Then there we go, nice holes. We got our Erlenmeyer all set up. All right, next up we want to transfer about 5 mLs of our unknown. So I've got my unknown right here into our apparatus. So take my graduated cylinder here and pour about 5 ml. Doesn't have to be exact. Cool. So overshot a little bit, but still approximately 5 ml. Take apart my apparatus over here and pour my unknown into my Erlenmeyer. Then recover with the aluminum foil. Small tear, but that's okay. Cool. All right, next up we got to set up our hot water bath. So I got my beaker half filled with water. I got some of these boiling chips right here. I'll add the boiling chips to the water. And now I'll go ahead and set up my Bunsen burner apparatus. Clamp down the Bunsen burner to make sure it's not going anywhere. Ring stand. Gauze wire. Another ring stand up here. Put my water bath in here. Oh, whoops, gonna have to switch those out. Go. Thermometer. Water should be about 100 degrees Celsius, so we want to make sure that reading's pretty clear. Apparatus should be good to go. Next up, we want to heat our water to a boil, and so we'll turn the gas on, use our striker to light our Bunsen burner, and then adjust the flame as necessary. This looks pretty good. We won't go for the tip of the inner cone this time because we want it to boil pretty gently. All right, you can see we are at a nice boil, so let's go ahead and turn the heat off and add our Erlenmeyer with our unknown into the water bath. Add some water to get the water as high up as we can get without worrying about it spilling over. Turn our heat back on. And then we're going to watch for all the liquid in the Erlenmeyer to evaporate or boil away. See in the bottom, there's still plenty of liquid in there. We just got started. All right, so at this point, there's no more liquid down here, so we'll give it another about 5 minutes and then take it out and take our recording for measurement. All right, been about 5 minutes. So let's go ahead and record the temperature, and then we'll take our apparatus out of here. About eye level, move this camera up. Go ahead and make your reading. Remove that Erlenmeyer and then just let it cool to room temperature and then weigh it. All right, so our Erlenmeyer's cooled down. Want to go ahead and weigh it. You see it's already tared, nice and zero. Let's go ahead and weigh it. All right, next up, we got to figure out the volume of our Erlenmeyer. So I've cleaned it out, emptied it out, that way we're not cross-contaminating anything. Fill it up with some water, fill it up to the brim, and I'm going to pour that water in my graduated cylinder and see what my volume is. Let's go ahead and do that. Fill it up very close to the brim, as you can see, and then just use this pipette here to top it off a bit. Cool. Looks good about there. I'm going to transfer this water into my graduated cylinder so I can see what the volume of my Erlenmeyer is. Since it's all totally full, I'll use this pipette to just get rid of the top layer. That way I can easily pour after that. Cool, and after that I'll just pour the rest of it into my graduated cylinder. Try to get pretty much all of it in there. And I'm going to go ahead and read my graduated cylinder to tell me what amount of volume I have. Go ahead and take your reading. All right, next up we need to read our pressure. So we're going to use this right side here. So this is going to measure in centimeters of mercury. So you need to switch that over to millimeters of mercury or whatever unit you kind of want to think about. So go ahead and take a reading there. Let me try to focus it in a bit.